Another way to solve systems of equations is to use what's called the substitution method. Here's an example. If we were going to solve this system, it's two linear equations, 2x minus y equals -5 and y equals x plus 4. Remember, what we're trying to find is a particular ordered pair, x, y, that is a solution to both equations. Now, it could be true that these are parallel lines and there will be no solution, or that they're the same line and there'd be infinitely many solutions, but usually we'll find exactly one ordered pair. So this means the value of y in the second equation is the same as in the first equation. So if one of the equations is solved for x or for y, we want to substitute that value into the other equation. So in this particular problem, notice that y equals x plus 4. I've already solved for y, in other words. So what I'm going to do is take that value, x plus 4, and plug it into the other equation. So the other equation, 2x minus y equals -5. This y you can replace with x plus 4. Alright, so let's do that. Instead of writing y, we're going to replace y with x plus 4. Now what we have is an equation with just one variable. Alright, so we need to do the distributive property here. 2x minus x minus 4 equals -5. I'm going to combine like terms on the left, which is going to be x, and at the same time I'm going to add 4 to both sides. So x equals -1. This gives us the x coordinate of our ordered pair. So we know that in our solution it looks like the x value is going to be -1. Now we need to find out what the y value is. Go back to the original substitution that I circled, y equals x plus 4. And now that we know what x is, we could plug it in for x. So now we could plug in -1 for x so that we find the y value. So if I didn't make any mistakes, it looks like that is the solution. But of course, easy to make mistakes, we want to check our work. So let's do a quick check in each of the equations. So I'm going to check -1, 3 into 2x minus y equals -5. So I need to put in -1 for x, 3 for y, see if that's -5. That gives you -2 minus 3 equals -5. That checks out. Now let's check the other equation, which is y equals x plus 4. Plugging in 3 for y, -1 for 4. Yes, 3 is the same as -1 plus 4, so it checks. So this indeed is the correct ordered pair solution. Remember, you're looking for an ordered pair that is a solution to both of the original equations. Here's another system to solve. 3x plus y equals -14 and 4x plus 3y equals -22. Notice that neither equation is solved for x and neither equation is solved for y. What you're going to look for to make this as easy as possible is if there is a single value of y or x where the coefficient is just 1 or -1. If you choose to solve for that variable, you won't have to divide by a coefficient and deal with fractions. For instance, in the first equation, if I wanted to solve for x, let's just see what that would look like. 3x plus y equals -14. If I solve for x, I would subtract y from both sides. Then I'd have to divide by 3, and x would be -1/3 x minus 14/3. Ugh, that'd be yucky to have to plug into the other equation, all those fractions. So, not easy. But if we solve for y, since there's no coefficient except 1 or -1 in front of y, it'll be easier to solve for. So in this particular system, there's only one variable that's really easy to solve for, and that's y in the first equation. Sometimes all of them are easy to solve for, or two of them are easy to solve for. And if they all have coefficients, none of them are going to be easy to solve for, and we'll do it a different way. All right, so if we were going to solve for y, I'm just going to say this is the same equation. Notice I do not use an equal sign. This is an implies sign. It's like two parallel bars with an arrow pointing. If I solve for y, subtract 3x from both sides, and now that's the same value as y, right? So I could plug that y value into the other equation. All right, so now let's do that. We're going to plug that into the other equation. 4x plus 3, remember your parentheses, -3x minus 14. Plugging that in for y equals -22. And we have an equation with one variable now. I'm going to have to do the distributive property first. Minus 9x and minus 42 is -22. Okay, I'm going to add 42 to both sides and do 4x minus 9x on the left. So 4x minus 9x is -5x. I'm going to add 42 to both sides. So that's positive 20. Right? And divide by -5. So I got the value of x is -4 if I didn't make any mistakes. So I'm going to say this time I got the value of -4. By the way, in both of the examples I've done, I solved for x first. So I substituted for y and I solved for x. That's not always true. You can substitute for x and solve for y as well. Okay, so we now know the x value. Go back to the original substitution right up here where it says y equals -3x minus 14, and now plug in the value you got for x, which is -4, which is going to be 12 minus 14. This works better on a big piece of paper as opposed to a small section like I'm doing online here. But if you have take some space. It should take at least a half a piece of paper to write this out, and so it's organized and you could find where your substitution is. So I've got that y equals -2. So now I plug that in over here into my ordered pair. So this looks to be the correct ordered pair. Now we want to check this in the original two equations. Always check it in both equations. Alright, so I'm going to have to scroll down to find room to do this. I'm going to write the two equations here. 3x plus y equals -14, and the other equation was 4x plus 3y equals -22. Alright, so let's do this. We're going to check. -4, -2 into both of these. Okay, so into 4x plus 3y equals -22. I'm going to put -4 for x, -2 for y, and we have -16 minus 6 is -22, which is true. So yes, it's a solution of that equation. And then we're going to check it into 3x plus y is -14. So we're going to put in -4 for x and -2 for y. -12 plus -2 equals -14. Now really do the arithmetic and make sure you really do get the same number on each side, because if you don't, that tells you to go back, start the problem over. It's easier to start the problem over than try to find your mistake. So the answer to this problem really is the ordered pair -4, -2. Remember to write it as an ordered pair, parentheses, the x coordinate, comma, y coordinate, and the close parentheses.